I still remember a couple of the early discussions that I had that gave me confidence that we were really onto something. And one of those discussions, which I've written about, is I was at an early eVTOL conference. It was, I think, the first Uber Elevate conference. And so everybody was talking about vertiports and passenger, capacity and battery capacity. And then there's this one guy from the Army who got up and gave a talk about cargo and logistics. And he said, "Hey, I think this technology that y'all are developing for passenger transport could really make an impact in the Army, where we need autonomous cargo drones to carry pretty heavy goods from one place to another." And that was a light bulb moment. The world needs this, and nobody's doing it yet. Eventually, somebody will. This is inevitable, but we can be the first to do it because of our backgrounds and the moment we're in and the kind of team we can build to rally and build Chaparral, which is our cargo drone that we have in development now.
Welcome to Hangar X Studios, where former fighter pilot and host John Ramstead takes us on a journey across aerospace as it enters an historic period of innovation and transformation. Our guests include aviation experts, pilots, financiers, military leaders, and innovators of all types. Buckle up for another episode of Hangar X.
All right, welcome to Hangar X. This is the place where innovators, entrepreneurs, investors come to get the information that they need to make decisions about the future. This is the place where we are sharing what is happening, groundbreaking advancements, and today we're excited to have on Dave Merrill from Elroy Air. Dave, welcome to the podcast.
Thanks so much. Happy to be here.
Well, it's great to have you here because you know what? There's so many groundbreaking things that you've done. You're this visionary. You launched Elroy Air, and we're going to talk about your vision, but you wanted to create autonomous cargo. You wanted to hit the mid-mile logistics space. Like, you had a clear vision. Some of the other things you've done, first in flight of a turbo generator hybrid electric VTOL, which is fascinating. We had Vertigo on and some other companies that we're bringing on that are actually, I think that is going to be a huge future for this industry. You have a number of purchase commitments. Things are taking off for you. And you are reshaping logistics and aerospace as they come together for both commercial and the military. And I really think you're poised to be a transformative technology. I think the word Elroy Air in 3-5 years from now is going to be a household name. I think you're going to see it globally. But here's where I want to start, because you started out this background as an engineer, software. You have this love for photography, got you into drones. And now all of a sudden you're building basically one of the biggest drones on the planet that's being deployed. And I want to know, what was that vision behind launching Elroy Air? Because if I understand it right, when you launched this, the market wasn't there, or you didn't even know if the market was going to be there, but you had this big vision, and this vision started to map into a market that materialized. So what allowed you to just make this huge leap from what you were doing to launch an Elroy and getting funding and starting a company?
Sure. Well, I'm an engineer, so I've always had a nose for things that are useful, like looking for applications of technology that's right on the cusp of being ready to put to work and building something that creates utility out of it. And I was originally interested in drones through a lifelong passion for photography, like many people doing drones were 10, 15 years ago. So I was, strapping GoPro cameras to really DIY multicopters and sending them up on interval to take photos. And that opened my eyes to all the possibilities. And previously, I'd had a career in research, hardware, software, sensor-based interactive systems, and consumer technology. And this was just the coolest thing I could imagine. And so wound up working for a drone maker, an American drone maker, building a consumer drone for a couple of years, and then recognized, hey, there's a lot of these learnings that I could put to work to fill a gap in the market where something doesn't exist yet that's going to be super useful. And so started this company about 8 years ago. And I still remember a couple of the early discussions that I had that gave me confidence that we were really onto something. And one of those discussions, which I've written about, is I was at an early eVTOL conference. It was, I think, the first Uber Elevate conference. And so everybody was talking about vertiports and passenger, capacity and battery capacity. And then there's this one guy from the Army who got up and gave a talk about cargo and logistics. And he said, "Hey, I think this technology that y'all are developing for passenger transport could really make an impact in the Army, where we need autonomous cargo drones to carry pretty heavy goods from one place to another." And that was a light bulb moment. My co-founder and I
Well,
went
and I'm
over
also
and
thinking, having been in the military, Dave, this is right. You have troops that are forward deployed, and to get them cargo, you either have to put a helicopter out there, so you're putting lives at risk and very expensive machines at risk. Sometimes it's contested airspace. Sometimes the supply chains, even to get there, it's hard to get things close enough to deliver them by truck. So I'm guessing as you were probably listening to this, you're realizing, you know what, there is a real problem that needs to be solved for these guys, isn't there?
Yes, absolutely. And I learned about the risk that is present when you drive, logistics convoys on the ground and there's IEDs, or you fly a Black Hawk helicopter and that can get attacked. And so the promise of big autonomous cargo drones that carry material from one place to another in the military, it's a no-brainer. And it just didn't exist yet. But the visionary folks that I started to meet as I went down this path of figuring out what do we need to build and is there a market for this, they all saw a similar thing, which was the need for an autonomous aircraft that could carry a few hundred pounds, go a few hundred miles, and deliver without putting any lives at risk, and just go back and forth and do this cargo delivery job all day long. One of the things people say about robotics, the old adage is that they're for jobs that are dull, dirty, and dangerous, right? And so here's a dangerous job that you could do with a cargo drone if you had a cargo drone with the right capabilities. And so that was a galvanizing moment. I also met some of the visionary people at FedEx. I also met some of the people in humanitarian organizations like the World Food Program that were looking for ways to evolve past the use of old helicopters that were dangerous and expensive to do a lot of the logistics that they do. And it was enough of a triangulation of the need that I heard from these different groups that I got conviction, and my co-founder and I decided, okay, we got to build this. The world needs this, and nobody's doing it yet. Eventually somebody will. This is inevitable, but we can be the first to do it because of our backgrounds and the moment we're in and the kind of team we can build to rally and build Chaparral, which is our cargo drone that we have in development now.
Yeah, and if you guys are interested in checking this out, if you're not familiar, it's elroyair.com, correct, Dave? And you can see
That's
all
right.
the videos on the Chaparral. There are so many great things there. And take me from that point forward, because I actually just read this fantastic book called Unit X, and it's about the Defense Innovation Unit. And it's been, it started under the Obama administration, and it has been a long run to bring Silicon Valley level expertise, ingenuity, and capital into the defense sector. And it's starting to mature, and out of that became Shield Capital. But your Elroy Air is in there and highlighted as a success story. And I'd love to talk about from that first point when you guys said, okay, we're going to start. And what was it like when you got there and working with Shield Capital and DIU? And in addition to capital, is there anything else that they added to what you guys were doing and developing?
Yeah, let me talk about Shield Capital, because I met Raj Shah
Mm-hmm.
before Shield Capital was even started, and he recognized the value in what we were doing, and so he actually became an angel investor in Elroy Air. Like immediately got the need, saw that we were dedicated and we could build the right team to do this, and then as Shield Capital was stood up as a venture firm, we became one of their first meaningful investments. And so they've been a longtime supporter. It's great to have a domain specific investor, or let's say an investor who's a domain expert, because it's like having an advisor right there who knows our market the part of our market that is selling into the military, to the U.S. government. Raj and Philip have collected and assembled this team of amazing Americans who are all mission oriented, trying to back startups like us to get our systems to the finish line and out and into use with the military. And mostly these companies like us are dual use companies where there's a big
Right.
commercial market and there's a military market, and we can build essentially the same technology to serve both markets. So it's been great having these folks on board with us.
How did their input shape your approach over time?
It one of the things that I could say that's concrete is a company like Elroy Air needs to be able to get into the right rooms, meet the right people, have conversations with the folks who can ultimately become the customers of our systems. And Shield helped us to meet and bring on board this amazing advisory board of folks who are ex-military generals and others who have become this sounding board for myself and the executives at Elroy Air, and who've been there, done that, have connections, can plug us in to talk to the right people, give perspective when the sales motion or the business development motion needs some input or is confusing because it's a pretty complicated environment, as any dual use startup will tell you, to sell into the government. So they act as not just money, not just capital, but as an advisory resource and a networking resource too.
Yep, it's better to have smart money, wise money than just an investor for sure. And you guys adopted hybrid electric when everybody else was focused on pure electric and electrification. And early on, that technology was not mature yet. So what were you seeing at that time that maybe others weren't seeing?
Well, we were seeing the way we needed to fit the operational need. And like I said, we'd excuse me, we'd had these discussions with logistics visionaries who could see over the next hill and understood the potential of cargo drones, big cargo drones. And when we looked at the capabilities of electric propulsion at the time, electric propulsion is great. The motors, the kind of rotors you can use, the kind of redundancy you can get if you have enough rotors so that even if something goes wrong with one of them, you've got others to take over and keep the vehicle safe and completing its mission. But batteries are still far behind liquid fuel in terms of energy density. And so we ran the numbers early and figured out, okay, if we're going to meet this operational need that we're hearing about from the Army, from humanitarian aid organizations, from FedEx, this can't be a battery electric aircraft because we just won't get the operational range.
Well, plus also in remote areas, you don't have access to anything that could charge it meaningfully, but you do have access to
Exactly.
fuel.
Bingo. Yeah. So that's the other thing, is that the kind of the real operating scenario is not going to have access to a bunch of charging infrastructure, at least for a long time. So we started working 5 years ago now on a hybrid electric power plant for this aircraft, and did our first engine runs with a turboshaft engine 5 years ago now. And
There's some
built
pretty
the
small
hybrid
compact
electric.
turbine engines, aren't there?
Well, you'd think so. There's actually not a lot of options at sort of every spot in the power output spectrum. And so we had to search the planet far and wide to find a turboshaft engine that had the right power output for what we needed. And even had a couple false starts with companies that were building something that was going to solve the problem, but then it took them longer to do it because this stuff is hard. And so we actually ended up integrating our own turbo generator using an off-the-shelf engine, off-the-shelf generator, electric motor, electric machine, and then doing all the mechanical integration and cooling, and importantly, software that stitches these things together to create a functional turbo generator for our aircraft that is pretty unique. And there's a lot of things that are hard in developing a new turbo generator, but that power management of keeping the turbine in lockstep with the generator to meet the system's power needs, and coordinating that with the battery, because we do have a small onboard battery. Keeping all these systems working happily together has been a real technical innovation that our team has done.
Yeah, it's a lot more complex than it sounds. What are some of the problems you guys had to overcome solving that challenge? As an electrical
Well, I'd
engineer,
say, yeah,
I'm fascinated with this whole area, but it's definitely complex.
yeah. I mean, at a high level, you've got a electric VTOL aircraft where the propulsion is all electric motors, right? And there are moments during flight when suddenly that vehicle needs a lot more electrical power, so it needs to pull a lot of current, and that's typically during takeoff and landing when all the vertical propulsion is going, or in moments of disturbance rejection. And so you need a system that can respond rapidly to, changing power needs. And responding rapidly is something that batteries do really well, but turbo generators don't, because a turboshaft engine, has a slow spin up time and spin down time. And so it's not, it's good at providing a fixed amount of power in a steady way, but it's not good at really quick spikes. And so that was where I said we did a bunch of innovative engineering work, uh, primarily in software, to stitch these systems together and and allow them to both provide power, the battery and the turbo generator together, to meet the vehicle demands, and then hook that into the vehicle's system, so the vehicle is always demanding an amount of power that the power plant can actually provide.
Yeah,
And
it's fascinating,
all
right?
these
Because
things,
you have to take a turbine
yeah,
that's turning at a constant speed, but you have a very variable demand on the power, both for vertical flight, and then when you said turbulence or disturbances, that's just gusts and winds and the flight control system keeping that load steady, and it's gonna increase the demands quickly, isn't it?
yeah. So one way to think about it is that this is a vehicle with electric propulsion and a range extender, which is this turbo generator. And one more thing it'll do is recharge the battery. So it'll draw the battery a little bit, draw down, use the battery a bit during takeoff, gets into forward flight, wing-borne flight, and then it will be able to top up that battery back to a full state of charge during forward flight, so that by the time it's ready to land, it's going into landing with a full state of charge on its internal battery.
So the battery becomes that buffer for that unequal demand, and
Yeah,
probably gives
yeah,
you a reserve in
exactly.
case something happens to the turbine. I can set the load down, and then I can
Yeah,
go.
you got a little bit of reserve. You
Yep,
don't need a lot, because you don't want a lot of battery, because on a
it's weight.
battery electric aircraft, that's the heaviest
Hmm.
piece of the mass fraction. And so the smaller you can make that battery, you do better on overall system mass. You get more payload, which is good for the use case.
Now you also designed this to be autonomous. And I'd love to share about the team. I'm guessing the coding and the thought that went in actually to truly make this autonomous. I'm just thinking about myself in the field. I'm an Army guy, and I'm like, okay, I'm here. I've loaded this. It needs to go here, so I put in the coordinates, and then it's going to need to know the terrain and map itself. And it's supposed to get out there. I can radio ahead and say, hey, folks, it's going to be there in 32 minutes. I just launched it, and they're waiting out there, and they know where it's going to come in and land, so it's going to be predictable as far as defensive positions, things like that. So there's an incredible amount of thought and engineering, I'm guessing, that went into that system. I'd love to hear about that.
Yeah, well, the foundation of it is building an aircraft which flies itself in autonomously in a, let me call it an inner loop manner. So just the basic system stability of takeoff, moving through the air, flying from waypoint to waypoint. That's where we started, and you can think of it as like a capability stack, where the system needs to be able to fly in a stable way. It needs to be able to go through waypoints in a predictable way as a core capability, and so that's where we've started. The ultimate user experience is going to be very much like what you said, where you send it out, you tell it, I need to go here to here, and it takes care of the rest. And, radios back its position along the way. You can tell it to deviate if you want it to, but otherwise it's going to just go from A to B. like a lot of drones do today. Waypoint based autonomous drone flight is something we've been doing for a long time. So, fortunately, we didn't have to reinvent that. But this integration with the customer and figuring out exactly how they want to task the system, that's what we're using our government and military contracts to do, to get closer to that customer. We just started an Army contract earlier this year that's going to be focused on ways that the Army can use the system, including being able to drop cargo if it's not safe to land, or if you don't know enough about the delivery site to know that the aircraft can go and land in a safe spot. Get close, get low, and then drop the payload. So there's a bunch of, let's say, human machine interaction.
So drop the
that we've
payload
got to get
without
right.
landing the aircraft.
Yes,
So a
because
low
the
hover, and I
default.
drop it, and then it leaves.
Yep. The default that we've designed the system for is to pick up the cargo robotically on the ground. So the aircraft actually, in our first prototype, has been able to navigate on the ground with wheels. So it actually drives itself to the cargo, picks up the cargo, will take off, fly A to B, land, navigate to the destination spot, deposit the cargo on the ground, can get a new assignment, go over and pick up the next pod. So that's full automation. And that's likely what our commercial customers are going to want, because they're running warehouse to warehouse and they want it to be as zero human touch as possible. So the aircraft being able to pick up and drop off the payload means that they can just have their warehouse robots move the payloads out onto the flight line. Our aircraft comes back, picks off the next one, takes it, comes back, picks off the next one, takes it, and that loop just goes and iterates. In the field with the military, they are going to need to handle a wider range of terrain for landing. And so one of the things we've been exploring more recently is putting skid landing gear on the vehicle, so that it's got a wider landing base and it can land on grass and bumpier surfaces. And so we're exploring, what does that mean for the concept of operations of this aircraft for the pickup and delivery of cargo. And so this Army contract I mentioned, its main purpose is to explore that scenario of getting to the delivery site for cargo, and then getting low, and then dropping the payload to get to its destination.
Now, is it going to fly at a constant altitude, or can it do terrain following?
It can do terrain following, within the constraints of climb and descent rates of the vehicle. It flies on wings for the majority of the mission. So it's not quite as nimble for, what gets called nap of the earth terrain following as a pure rotorcraft. But it can go low. It can follow the terrain.
Yeah, that's, I'm thinking there's situations, mountainous areas where I'd want to be low and as quiet as possible to try to get in. If I have let's say a SEAL platoon forward deployed, and I need to get them, they've been out there for 2 weeks, I need to get them some gear. You want to try to even mask your ingress and egress, so that I might not be able to figure out if I even see it. I still can't tell where the guys are, right? I could map out a course like that.
Yep, and that's the kind of operational input that we're going to be getting from our Army contract and other military partners to build into the navigation interface, so that our partners that are deploying these systems have as much flexibility as they need to design a mission.
Now, I got to ask you, so here's a question for you, because, which is remarkable, and congratulations on your success. You have $2 billion in demand right now, which has got to be exciting for you and your team, from what I understand. Was there a tipping point when you realized, okay, the market is ready for this, and things started to take off, and did that surprise you?
The early moment of understanding the market need was really these discussions that we had in the first year of the company.
So you knew
Where,
early
like I
on the
said,
market was there. We build it and they will come, and that actually really worked for you guys.
yeah, I mean, humbly, we knew there was a lot we needed to learn about exactly how this system would be operated. And so our partnerships with customers are allowing us to try out ideas and iterate that operational concept and interface. But the early feedback that told us we can build an autonomous cargo drone that can carry a couple 100 pounds and go a couple 100 miles, there's going to be a lot of people that will use that, a lot of organizations that will use that. That part's been constant all the way through.
Yeah, and something you guys did that I thought was really smart is you really kind of containerized the cargo pod that it holds. So, load planners, logisticians, whatever that version is in the civilian world, I know exactly what the space is and how to load it and what I can put in there, the weight limits, the size. So then I can have that for my different missions.
Yep, we call it a cargo pod,
Yep.
and it is we've standardized the mechanical interface so that the aircraft can pick up and deposit cargo pods, but it allows for a lot of flexibility on the payload itself. So we get feedback about the dimensions of it, like could you make it bigger? Yes, we can make a bigger one as long as the aircraft can still pick it up. Could we make a powered cargo pod if you need refrigeration or power to drive, electronic jamming or other spoofing or signal relay, communication relay out of that cargo pod. So you can think of the aircraft as like that's the platform. The pod is the application that runs on the platform. And it means that we don't have to have imagined every use case for this vehicle. We just need to make the best pickup truck of the sky. And our partners will develop a lot of use cases for it beyond the initial cargo. I do think cargo logistics, that's the killer app. Like that is the thing that Chaparral is best at and that we're designing it for. And I think, fast forward 5 years, 10 years, like that is the vast majority of what the system is going to be doing is just these conveyor belt through the sky routes from one place to another, driving, a few 100 pounds of cargo back and forth.
Yeah, and we've talked about some of the clear, I think, military use cases, but talk a little bit about what Bristow's doing, what they're testing this for, how they would employ it. They're one of the biggest helicopter operators in the world, and then we'll get into some other use cases.
Yeah, that's right. So they're a great partner. They're innovative. They're one of the biggest helicopter operators. They're picking up new platforms and figuring out how they can put them to work alongside their existing fleet. And so what Bristow wants to do is put Chaparral vehicles into their fleet to create a cargo capability, a logistics capability at lower cost than flying a manned helicopter, and
Yeah, and
at
just as
lower
for
risk.
reference, today almost all everything they fly out to the oil fields are twin engine Sikorskis, and those are thousands and thousands of dollars an hour to operate.
Yeah, they're awesome. They're exquisite aircraft. They're amazing. But if you have missions, which they do very frequently, where you're just carrying some spare parts or tools or things, not carrying people out to these locations, then an alternative vehicle that's smaller and lighter and lower cost to operate makes a lot of sense. So, they're still going to keep doing the majority, I'd say, of their missions, carrying people, flying very exquisite aircraft. But they see the future that there's also this new vein of business they can do if they've got a system like Chaparral.
Well, here's the interesting stat for you. So I was reading a report from the U.S. Navy. I think this was from 2 years ago. I think there was just over 3,300 critical cargo, what do you call them, missions. From a 2-pound part because this thing's the catapult and the carrier's not working, but I need this bolt or whatever it happens to be. And there was 3,500 of these, and 90% of these were under 50 kilos. And they're delivered by CODs, the carry on board delivery, Blackhawks, and Osprey. So I mean, just think about that as a use case in just that space. And so, what are some of the other use cases you're seeing? And I bet a lot of the use cases that you're going to be seeing in the future, you guys haven't even thought of yet, as your users start to go, wow, we could do this.
Yeah. So beyond the energy market, humanitarian aid and delivery, there's a lot of old helicopters that get contracted to fly humanitarian aid, which is things like food supplements, blankets, medicines out to places where they're needed, and big delivery drone that can carry a pre-packed aid bundle, whether it's food or water or shelter, can just do this kind of an aid route all day long at an operational cost that's lower than manned helicopters.
Hey,
So that's
what?
one that I'm really excited about. That's kind of adjacent to disaster relief, which is also going to be, I think, a key use case.
Well, I think so too, because like even think about Hurricane Helene. The if you actually analyze the helicopter deployments, because everything's destroyed. So first of all, finding places where I can refuel and even fly from was a challenge at first. But 50% of their missions were search and rescue. The other 50% were logistics. Imagine if I could stage from 50 or 100 miles away. What's the range of the Chaparral in the Endurance? I forgot to ask you that.
Yeah, so we're designing for a 300-pound payload and a 300-mile range.
So I could fly 100 miles and come back 100 miles and then refuel it.
Correct.
So think about if
Yep.
you had a fleet of Chaparrals that were bringing in water and food and medicine and blankets into even Hurricane in North Carolina, and you'd free up all those helicopters, a majority go do search and rescue. Imagine maybe another 50 or 100 lives could have been saved, future hurricane, because we'll have these kind of capabilities to free the helicopters up to what they're best used for in a situation like that.
It's a perfect way to think about it, because we're not trying to obviate helicopters. There's
No,
a ton of need for
there's a place
helicopters,
for helicopters, and that'll never go away.
yep, and like you suggested, they're often in short supply when something happens where you need them. And so the ability to keep helicopters focused on the missions that they do well, heavier payload, carrying people, and free them up to do more of that, while we can do this pickup truck through the sky cargo back and forth all day long. It's going to be an amazing expansion of capacity.
Yeah, and you could be at an undamaged airport 20, 30, 40 miles away and just be doing round trip, round trip, round trip.
Yep,
It'd be
yep,
interesting to just,
exactly.
think about that. Right? If you have a ground crew there waiting for it, they unpack the pod so it can carry back the empty pod to be reloaded. But as soon as it stops, they throw in a full pod and reload that while it's doing its next round trip. And you're just, creating multiple daisy chains to the areas that need it. It'd be pretty incredible.
Yeah, or think about pods, preloaded in a shipping container. You've got a certain bundle, let's say, kind of a relief bundle pod, and you've got 20 of them, you've got 50 of them stacked up in shipping containers. So you just start pulling these out, and then Chaparral starts taking them to the point of need, and you just literally have this conveyor belt through the sky of getting these pods to where they need to go.
Okay, there's somebody I have to introduce you to after we'll talk about it that needs this capability. I think it could open up an entire whole new market for you, Dave. You just gave
Sure,
me an idea.
sounds good.
All right, so we talked about hybrid electric. We talked about the flight control system. Was there any your team? I'm sure you had to solve a lot of problems, but was there any operational or technical challenges that really stood out to you? Like, you know what, man, that took a lot of work, but we finally did it.
Well, hybrid electric was one. That's a great example. One of the other things that I am proud about that our team did is the rigorous pipeline of testing and simulation frameworks and tools and systems that we've built to validate our software on the way to putting it on the full-scale Chaparral. So this is something that our team has been also building for years. Same vintage of when we started this effort as the hybrid electric powertrain. But we've built a system of simulation. So we write code, run the unit tests, then run it in a simulated environment where we're actually flying a simulated mission, running real flight code, simulated aircraft, simulated subsystems on the aircraft, all hooked up, in sim in the way that they are in the physical system. And we can run flights on the code in simulation first, which is very fast and cheap, and it kind of a good first check. Then we've built a hardware in the loop system. So this rig is like the nervous system of our aircraft on the bench top. So it's this big tabletop version of all the avionics boxes that exist on the real thing, and it runs with the software simulation. So that if there's any problems that have been introduced by a new software build that would only show up on the real hardware, we can find it in the hardware in the loop sim. And so run a bunch of tests on the hardware and the loop sim. Then we take that code and we put it on a subscale aircraft, which is about a 1/3 scale Chaparral. Also has the same avionics architecture on it. And we use that to run full missions, including full autonomous missions, make sure we shake down any bugs that might be latent that we'd only find in flight. Then we put the code on the full scale aircraft. Sometimes we run tie down testing there where it's strapped to the ground and we're powering up and making sure that everything, all the levels and responses are looking right. And then finally, we go out and fly the system. So it's this pipeline of different checklists, basically different steps that we take and put this software through to really validate it by the time it gets to the full scale aircraft and goes into flight. And finding problems and fixing problems at any of these steps along the way means that we have more successful flight tests on the full scale system. So that's behind the scenes. You don't see that if you just go and watch the aircraft fly, but that rigorous pipeline of checklists and tests is part of the secret to our success too.
Yeah, but I could tell as you were speaking, Dave, that tapped into a passion of yours, didn't it? This is the part of it that you really love, isn't it?
Yeah, I mean, this is the in the weeds of developing complicated technology is the kind of things that you build to enable yourself to build the the big public facing thing, the aircraft itself. A lot of great engineering our team has done in service of building Chaparral.
Yeah, and I'm guessing too, if I owned one of these or a fleet of these, and you guys improve things, I'll be able to get an over-the-air update, right? I'll and then be training and say, hey, here's the release notes. We enhanced this capability. We added this. The app is now has this. Is that how it's going to work?
Yeah, I mean, we're going to make sure it's ready for prime time and ready for customers by the time we hand off systems. But if we improve things, if we update, we'll be sure to make those updates available to our customers too.
Yeah, love that model. And now you've recently kind of moved into the role of executive chairman. So I'd love to hear about like what's next for you personally.
Well, executive chairman for me is full time Elroy Air, and it's in a
So
way it's
nothing
back
changed
to
really.
not a lot. I mean, I'm not the CEO. We hired a great CEO, Andrew Clare, who has an aerospace background, was a aero astro PhD at MIT back around the time I was there, and has been working in the autonomy field. Worked at Tesla, worked in ground autonomy, and so he'd been looking for a way to get back into aerospace. And about that same time, I was looking for a CEO to hand the baton to, so that I could kind of show, and it would fit. And so he's been on board since December. In a way, for me, this has meant back into what feels a little bit like early stage founder mode. Like I get to step back from being the guy making a bunch of decisions every day to the guy supporting and figuring out, do I need to go and run an errand? Am I going to go talk to a team member? Am I going to go contribute to an investor call? Like there's a pretty wide variety of things that I do that feels very, very much kind of like the early days. And so that's my role for now is kind of fungible founder executive at Elroy Air.
Well, I love that.
My
So
actual
yeah, and as we wrap up, let's just say, what does the 3-year vision look like? What are we going to be talking about 3 years from now, looking back on what Elroy Air is not only doing but accomplished?
Yeah, so in 3 years, we're going to have systems in the hands of our customers being flown every day. We're going to be in early production with a functional assembly line that's turning out Chaparral systems. And those systems are going to be running full end-to-end missions, creating value and reducing risk and reducing costs for our customers across military and commercial and humanitarian.
I love that. Well, Dave, you and the team keep doing amazing work. Keep knocking them alive out there. Thanks for coming on. And, any breakthroughs, advancements, anything going on with Elroy Air, please feel free to come back. We want to share that with our whole audience because you guys are doing, cutting edge work, but you're actually making it happen in a real way that's transforming the industry. So it's exciting.
My pleasure. Well, thanks for having me on. It's great to chat, and we'll keep in touch.
All right, you got it. See you, Dave.